In a solar system defined by order, Venus is an anomaly. While every major planet rotates in the same general direction, Venus turns backward, against the flow of everything around it. Even more disturbing, it rotates so slowly that a single day on Venus lasts longer than its entire year. This is a complete violation of the natural patterns that shaped every other planet, meaning something happened to Venus, something powerful enough to alter the rotation of an entire world. And whatever caused it left behind one of the greatest planetary mysteries in the solar system. While Earth completes one full rotation every 24 hours, Venus moves at a completely different pace. So different that it barely fits the models we use to describe a normal planetary day. It takes 243 Earth days for Venus to rotate once on its axis, making it the slowest spinning planet in the entire solar system. From the surface, the sun would hang in the sky for months at a time, barely shifting its position. But that's not the most unsettling part. Venus orbits the sun in 225 days, shorter than the time it takes the planet to complete a single rotation. In other words, a full day on Venus lasts longer than an entire year. And the direction is reversed. The planet spins backward, meaning the sun would rise in the west and set in the east, a complete inversion of the pattern seen on Earth and nearly every other world that shares this system. Nothing else this close to the sun behaves this way, and the numbers make that clear. Venus is detached from the original rotational pattern the rest of the planets still follow today. Now, the thing is, Venus didn't form spinning backward. When the solar system first came together, everything was moving in the same general direction, a spinning disk of gas and dust slowly condensing into planets. That shared rotation is why most worlds, including Earth, still turn the same way they orbit the sun. Venus should have followed that same rule. But the early solar system wasn't a clean, orderly place. It was violent. Planets were still forming, colliding, breaking apart, and crashing into one another at speeds that are hard to comprehend. For a world the size of Venus to end up rotating the way it does, something had to interfere with that original motion. One possibility is a massive impact, the kind capable of tilting an entire planet. A collision with a large, fast-moving body could have slowed Venus down, knocked it off its original axis, or even reversed the direction it was spinning. Another is something far slower, but just as powerful over time: the sun itself. Venus is closer to the sun than any other planet except Mercury, and that distance matters. The sun's gravity doesn't just pull on Venus as a whole, it grips its atmosphere, creating tidal forces that act like a brake on the planet's rotation. Over millions of years, that constant tugging could have drained Venus of its original spin, gradually slowing it down, and eventually flipping it into the strange backward rotation we observe today. There's also the atmosphere. Venus has an atmosphere over 90 times thicker than Earth's. That dense, crushing layer of gases transfers momentum. As it moves, it drags against the surface and interacts with solar tides, creating forces able to influence the rotation of the planet beneath it. It's likely that Venus didn't change because of just one event. It was probably hit, then reshaped over billions of years. That altered rotation has completely changed how the entire planet behaves. A slow backward spin means the same side of the surface spends an enormous amount of time facing the sun. On Earth, a region heats up during the day, then cools when night arrives. That balance helps regulate temperature and keeps extremes in check. Venus never had that luxury. With days stretching on for months, heat had time to build without relief. The surface absorbed more and more energy, and there was no fast rotation to distribute it evenly around the planet. That imbalance fed directly into what would become a runaway greenhouse effect. Oceans, if Venus ever had them, would not have lasted. Water vapor is a powerful greenhouse gas. As temperatures climbed, more water entered the atmosphere, trapping more heat, which caused more evaporation. Over time, Venus turned into a pressure cooker. Surface temperatures climbed past 460 degrees Celsius. Pressure at ground level rose to more than 90 times that of Earth. Once that state was reached, there was no natural way back. The slowed rotation completely removed the conditions that might have made it habitable in the first place. What makes this more than just a failed planet is that the process is no longer happening. Venus isn't still becoming this world, it already arrived. The rotation it has now is essentially locked in. There is no large moon to stabilize it, no magnetic field to shield it, and no remaining mechanism capable of significantly changing its spin on a planetary timescale. When we talk about the scarier part about its surface, which, if 460 degrees wasn't scary enough, the real unsettling part is the weather that comes with the rotation. High above the surface, winds often race around the planet at over 360 kilometers per hour, circling Venus in just 4 Earth days. This phenomenon, known as superrotation, means the atmosphere is moving more than 60 times faster than the planet itself is spinning. These winds carry dense clouds of sulfuric acid in a permanent global motion, forming a continuous storm layer that completely hides the ground from view. There are no openings, just an unbroken ceiling of toxic vapor wrapped tightly around the planet. And despite all of that movement, almost no cooling takes place. The atmosphere is so dense that heat becomes trapped and compressed near the surface. The air is no longer just air. It behaves more like a heavy fluid, holding energy in place instead of allowing it to rise and disperse. Thermal energy builds without relief, locked beneath the crushing weight of the atmosphere itself. What followed is a planet held in place by its own physics. And that's part of what makes Venus so important to study. Earth and Venus formed from similar material, with nearly identical size and density, and in the same region of the early solar system. From a distance, they should have followed almost the same evolutionary path. Instead, one developed oceans, life, and a stable climate, while the other slowed, reversed, and collapsed into an environment so extreme that even advanced robotic probes can only survive for minutes on its surface. The key difference between these planets was motion, a difference in rotation speed, and a difference in how long the planet was exposed to unrelenting sunlight, gradually led these two worlds toward completely separate destinies. Venus is what happens when a planet loses its balance and has no way to reset it. Just a small disruption in motion that grew into something irreversible.